In this video, we're going to look at questions 7 through 10 of the Chapter 3 practice test and finish off the multiple choice portion. Which of these is not true of the correlation R between the lengths in inches and weights in pounds of a sample of brook trout? So which is not true? So you have to understand our definitions. So we'll take the red marker and we'll go through this and cross off the ones that are true. So let's just do that first, as which is not true. So I'm looking for false on it. So I need to cross out the true ones. R must take a value between -1 and 1. Well, that's true. R is measured in inches. Now, a student might say, hey, you know what, that's true because I'm looking at inches and weights, but I'm going to mark that one. That one's actually false off the top of my head. Maybe it's not the most false, but I know it is because R, -1 and 1, there are no units for R. So I could tell you right now the answer is going to be B. But let's talk through the others as well. If longer trout tend to also be heavier, then R is greater than 0. Well, that's saying you have a positive correlation between it. So as the inches of the trout, so as it gets longer, so inches increase, then they will get heavier, the weight increases. That's a positive correlation between them. So this is true. R would not change if we measure the lengths of the trout in centimeters instead of inches. R would not change for choice E if we measure the weights. So these two are very similar. This was actually talked about in the first video, is that the correlation does not change when you convert between units because R is calculated from standard scores for it. So it is not D and E. B is wrong. R, there are no units for R. They are measured from standard scores in the case that we dealt with before. R is from standard scores, and maybe I should write down the formula we looked at before, is R is equal to 1 over n minus 1 times the sum of all the z-scores for each x times all the z-scores for each y. So R is calculated from standard scores, standardized units for it, which is why D and E are not correct. So that was from a formula that we dealt with before with R. But we need to know there's no units for R and that R does not change when you convert between units because it is converted from z-scores. It is found that way. Now, number 8. When we standardize the values of a variable, the distribution of standardized values has a mean of 0 and a standard deviation of 1. Suppose we measure two variables, x and y, on each of several subjects. We standardize both variables and then compute the least squares regression line. Suppose the slope of the least squares regression line is -0.44. We may conclude, well, I gotta read all this. When we're dealing with this one, I see the slope of the least squares regression line is -0.4. We standardize both values as a mean of 0 and a standard deviation of 1. We do that to both the x and the y. So what can we conclude? The correlation will be 1 divided by -0.44. So we do 1 divided by -0.44. Well, let me see. If I take a look at this, and I want to find this out, I'm going to take 1 and divide by that and see what I get. In this case, it's approximately -2.27. Well, R has to be between +1 and -1. So it can't be A. The intercept will be -0.44. Well, this one's tricky. I don't know about this one. Maybe I might have to try an equation for that. The intercept will be 1. Well, if I have to try an equation for B, I'm going to have to try an equation for C, and that might help me eliminate. The correlation will be 1. Well, a correlation of 1 is a perfect linear relationship, positive linear relationship. Maybe that's the key word I have to look at here is it'll be 1. It'll be a positive. But the slope of the least squares regression line is negative. What's a negative correlation? So there's no way it can be D. The correlation will also be negative 0.44. Well, it looks like that isn't the correct value, and it is negative, and we did discuss that it has to be a negative correlation. So let's figure out which one it is. We're going to have to look at our formulas. I see intercept, I see correlation, I see all that. Well, maybe I'm going to try this. I know y hat equals a plus bx. So there's an equation for the least squares regression line. I also have the formula b equals r times the standard deviation of y over standard deviation of x. And I have a equals y bar minus b times x bar. Remember, b is the slope. So these are my 3 equations off the top of the formula sheet that I have that deals with slope regression line. Well, which one is it? Maybe we have to look at the other values I'm given. I'm told the mean is 0 and the standard deviation is 1. And I did that for both variables for it. So let's see if I figure this out. Well, if the mean is 0, then I have a equals 0 minus my slope, negative 0.44, times the mean of x, which that's 0 as well. So a is 0. So my y-intercept is going to be 0. Well, hold on. That means the intercept will be negative 0.44. No. The intercept will be 1. No. So process elimination, yay, the answer is E, but we still need to know why it's E, because maybe I crossed off a wrong choice above. The correlation will be negative 0.44. Well, the only formula I have with correlation is right here. So my slope, negative 0.44, equals, I don't know R, that's what E is trying to tell me, standard deviation of the Y. Well, wait a minute, we standardized both variables to be 1. So 1 over 1. Well, of course, R equals negative 0.44 then. So what's up with this problem? It's tricky. I mean, I should not choose A at all because that gave me an R value that was not in the range. Right away, A is wrong. But B, C, and E, I was stuck on. I have to think about what that's saying. I could eliminate D as well right away because I'm told there's a negative slope and it's giving me a positive correlation. So there was no reason that I should have chosen A or D. Right away, those violate 2 quick definitions that we can do. But B, C, E, those are trickier. I had to think about what it's asking and think about what it's given me. It's given me mean values. It's given me standard deviation values. It's telling me we did it to both those variables. It's given me slope. It's asking about correlation. And so if I'm stuck and I'm given these values, I better go to my formulas, which the other video talked about questions 5 and 6 in that same sense, is we really have to think about applying our formulas when we're doing multiple choice. Sometimes it's multi-step. Well, the good news is if I picked one of them, I could have gotten the answer right away. If I picked the other, I could have eliminated both choices, but I'm always going to go through all of them to make sure, because the directions always say choose the best answer on it. So we know it's E because our intercept we found is going to be 0 for those. So now let's look at question 9 for this. So question 9, there is a linear relationship between the number of chirps made by the striped ground cricket and the air temperature. A least squares fit of some data collected by a biologist gives the model. y hat equals 25.2 plus 3.3x, where x is the number of chirps per minute and y hat is the estimated temperature in degrees Fahrenheit. What is the predicted increase in temperature for an increase of 5 chirps per minute? So what is this asking, or what is it giving? It's giving me my prediction line, which will be useful. It's defining my variables for me, which will also be useful. So let's think about that for a minute. Is x is the number of chirps per minute, which makes you want to say, well, wait a minute, this is our x, 5 chirps per minute, which is true. So I do know I'm probably going to plug that number in here. But let's just keep defining these variables. Y is the estimated, sorry, y hat is the estimated temperature in degrees Fahrenheit. That's this one. So if I plug in the 5, it's going to give me the estimated temperature. So what's the problem asking me to find is it's asking me to find what is the predicted increase in temperature, not the actual temperature, but how much is it increasing by. So this is going to be interesting. Well, let's just try and plug it in and see what happens. Well, right away, if I have y hat equals 25.2 plus 3.3x, what is the predicted increase in temperature for an increase of 5 chirps per minute? Well, if I plug in 5, and I'm going to do this 25.2 plus 3.3 times 5. Now, a student, you might go and type that directly in your calculator and get the answer. I'm going to take my time here to kind of make a point. I'm going to take 3.3 times 5 and get 16.5. Now, if I were to type it in my calculator in one go, I am going to get 41.7, which might make a student think that the answer is E. But that's not what this is telling me. This is telling me the predicted temperature when there are 5 chirps per minute is 41.7. That's not what the problem is asking me. The problem is asking me what is the increase in temperature for every 5 chirps for it. It's not E. E is the predicted temperature when there are 5 chirps. So that's why it's important we understand our variables. 5 does get plugged in, but what does it mean is we go through, it's not the predicted temperature. We're not looking for 41.7. We're looking for how much of an increase occurs for every 5 chirps of a change on it. So we read through this, we don't know what the actual chirps are. But let's try something. I see 16.5. I see 16.5. I'm leaning towards B because my y-intercept, my original temperature is 25.2. And I am increasing that by 16.5 degrees. Now that makes sense to me. What is the predicted increase? It's going to increase by 16.5 for every 5 chirps. Now let's look at number 10. A data set included the number of people per television set and the number of people per physician for 40 countries. The Fathom screenshot below displays a scatter plot of the data with the least squares regression line added. In Ethiopia, there were 503 people per TV and 36,660 people per doctor. What effect would removing this point have on the regression line? So that I have to kind of go through and find is I have probably looking at this point right here. That looks like it is the Ethiopia point. What would happen if I remove that line? Well, so I remove that point. Well, that point is influential. I mean, it's pulling up that regression line. So if I were to remove that point right away, that line should change. It should not go up as much, so it should decrease a little bit on that case. So there's an idea of what it look like. If I go through, it's going to look like that as it goes down. Somewhere along those lines is an estimate, which that looks like it decreased my slope. So I know it's not A, I know it's not B, I know it's not E. So it's either C or D. And this is a very interesting one because the slope did decrease, but look at my line. My y-intercept in this case increased for it. I mean, my choice is C. And it's a fun way to think about it. Don't ever think the answer is not going to be D. It's possible. Think about what goes on is when you have a least squares regression line, and I'll draw one, boom. Remember, it passes through the point X bar, Y bar every time, and that's kind of like the pivot point. So when you have a point up here, it's pulling it towards it. So if you were to remove that point, it's going to go down, and while this goes down, this side goes up. It's like a pendulum on it. It's like a teeter-totter, maybe a good way of saying it if you still remember those. And so now, if I'm looking at the other one, what if I have a point over here? And it's the same thing. It's pulling this side up. So if I remove it, it's going to cause this to go down, which is going to cause this to go up. So whenever you're removing a point, I think it's really important you understand which side of X bar, Y bar are you on. I mean, those are some tricky multiple choice can come in for it. It's not always going to have one effect. It really depends on which side of the teeter-totter, the fulcrum you're on for it. So again, like if I were to put a point down here, this is a fun one, is this, well, we'll actually make it more influential. This is a fun one. If I go right here, you have to realize this is pulling that down. There is a rope tugging that line down. So if I were to cut that rope, if I were to remove that point, it's going to snap the line up, which means my y-intercept, as this goes up and this goes down, my y-intercept would increase there for it. So it's very interesting to look at, and I went off on a sidetrack. What happens based off of what location you are in relationship to X bar, Y bar. That is key for determining this. Now, if I look at this one, I can see it's on the right-hand side. It was kind of easy to sketch. I would say the left side of your mean is going to be the trickier of them. But as soon as I drew what it said was going to happen, I could see right away the answer is C. Hopeful to kind of talk through them. I know it took time, but the idea was to explain not just which is the right answer, but why the other ones are not correct. So hope you enjoyed it.